Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Apollo 15, exploring new frontiers on the Moon. In 1971, Apollo 15 wasn't just another trip to the Moon, it was an epic scientific adventure. It was the moment when we went from simply landing on the Moon to conquering the Moon. And this time, the astronauts weren't content with just standing on the lunar surface, they brought along a Moon Rover. Imagine that, a vehicle that lets you drive on the Moon. Of course, like me driving to work today, the goal wasn't to just have fun, but to get the job done faster. It's simple, really driving gets you further in less time. And while I'm rocking a t-shirt, they're in full astronaut suits. But the goal of this mission wasn't just to take a few steps and grab some rocks. This was real scientific exploration, geological surveys, experiments, and tons of instruments to analyze the Moon like never before. David Scott and James Irwin weren't just collecting lunar rock samples, they were driving the rover across new areas to map out the lunar surface. The rover's introduction completely changed the game, no more relying solely on walking to gather data. They had a vehicle that could help them explore further, faster, and more efficiently. Picture this, driving a rover across the Moon's desolate, gray landscape with almost no reference points. It's easy to forget you're on a different planet altogether. But it wasn't all fun and games. The Moon's low gravity and extreme temperature fluctuations made the rover's design incredibly complex. Imagine having to start your car in temperatures of -200 degrees Fahrenheit, then hours later driving in a scorching 120 degrees Fahrenheit. Not exactly a regular commute. David and James used the rover to explore the Hadley-Apollo region, collecting about 77 kilograms of lunar rocks and soil. These samples were later brought back to Earth and became the cornerstone of lunar scientific research. But these rock samples weren't just Moon sand they brought back. These samples helped scientists unlock the Moon's history and even allowed us to understand how the Moon and Earth split from a common ancestor. David Scott and James Irwin's mission wasn't just about leaving impressive footprints in history, it was about bringing the first vehicle to the Moon, greatly expanding our scientific understanding of the Moon. And then, there was Alfred Warden's, the mission's unsung hero, who stayed in the command module. While David and James were out making history, Alfred was ensuring the whole mission ran smoothly, orchestrating every step from his spacecraft and guiding the team from above. Apollo 15 wasn't just a successful moon landing, it was more like a moon adventure. Scientists took the opportunity to study the Moon's surface structure in depth, conducting a series of experiments that laid the foundation for future deep space exploration. As the mission concluded, the Apollo 15 astronauts returned with a wealth of lunar samples, providing invaluable data for future lunar research and laying the technological groundwork for humanity's eventual journey to other planets. Now, let's start with our three heroes. First up, our moon racer David Scott. David Scott, the commander of Apollo 15, wasn't just an astronaut, he was the first person to drive a car on the Moon. Imagine navigating the Moon's gray surface, avoiding deep craters while collecting rock samples all while driving a rover. It's like being a race car driver on the Moon. But unlike when you zoom around the backyard in your toy car pretending to be a race champion, David's driving wasn't just for fun. The lunar rover was designed to handle extreme conditions, low gravity, temperature swings, and rugged terrain. It was basically an off-road vehicle designed for the Moon. David was a seasoned astronaut and a very hands-on scientist. On the Moon, he didn't just collect rock samples, he also made sure the rover was in top shape, ensuring everything was running smoothly. Without that rover, they would have had to walk to every geological site. Imagine the stamina required for that. What's also remarkable is that David's moon roving experience didn't just lay the groundwork for future missions, it helped scientists gather the lunar samples that remain essential to lunar geology and evolution studies today. But here's something you might not know, David didn't start off as a moon racer. As a child, he was more of a tech nerd. He had a passion for space, building models, and tinkering with things. He probably never imagined that one day, he'd be the first person to drive across the Moon's barren surface in a lunar rover. But hey, David truly brought his childhood dreams to life on the moon. So, the next time you're cruising down the highway or controlling a rover on Mars, just remember, it all started with David Scott's first moon drive. And while our moon racers had a blast, their mission wasn't just about taking a joyride, it set the stage for humanity's next steps into the cosmos. After the Apollo 15 mission, David Scott didn't exactly fade into the background of space history. Quite the opposite, he stayed deeply involved in the space program. Even after retiring, he took on key roles at NASA, managing space projects and contributing to scientific research. And, no surprise, he continued to offer strategic advice on lunar and Mars exploration long after Apollo 15. David officially retired in 1990, but he didn't stop there. He kept actively speaking about space exploration and engaging with the public about space technology. In fact, David Scott's life is a living testament to the spirit of space exploration and science. He dedicated much of his time to passing on his passion and experience to the next generation. Through his books, speeches, and outreach, Scott became an iconic figure, inspiring countless people to chase their own space dreams. Now, let's talk about James Irwin. Imagine this: without James, Scott wouldn't have been able to complete their lunar exploration. Besides grabbing that pickaxe to collect rock samples, Irwin was the one handling the Lunar Rover. Yep, it wasn't a one-man job. They worked together seamlessly to get the job done. Irwin didn't have the same driving thrill as Scott, but he had an equally crucial role. He took on tasks like photographing, conducting scientific experiments, and assisting with sample collection. It sounds simple, but in zero gravity, even the smallest detail was critical. Every single move had to be calculated to the T. Now, think back to Irwin's childhood. Maybe he didn't dream of driving a rover on the moon when he was a kid, but he always had a fascination with science. As a youngster, he was obsessed with cars and mechanics, even dreaming of becoming an automotive engineer. But life had other plans. He didn't become a car engineer, but he did become one of the heroes who made history on the moon. Irwin's lunar experience didn't satisfy his thirst for adventure, it fueled his desire for further human exploration. After retiring, he shifted his focus to charity and humanitarian work, especially in youth education. He founded the Irwin Foundation, dedicated to helping at-risk teens and encouraging them to change their future through science and technology. Unfortunately, Irwin's life was cut short when he passed away in 1991 at the age of 61. But his legacy lives on far beyond his time on Earth. His work in charity and the promotion of science education is still widely remembered today. Now, let's talk about Alfred Wardens. As the command module pilot, Wardens didn't step foot on the moon, but his role was just as important. You could say he was the behind-the-scenes hero, ensuring that communication between Earth and the moon remained uninterrupted and managing the command module. You see, the connection between the lunar module and the command module was crucial. Wardens was like the unsung backstage manager, making sure the whole mission ran smoothly. Without his precise handling of the command module, nothing Scott and Irwin did on the lunar surface would have been possible. Even though Wardens didn't directly engage in the moonwalk, his work was absolutely vital. He controlled the command module, ensuring proper navigation and communication, and provided support to his fellow astronauts on the moon. You might think this role doesn't sound as glamorous, but Wardens was carrying the responsibility of mission safety on his shoulders. He was essentially the logistical backbone of the Apollo mission, keeping everything running like clockwork. After retiring, Wardens didn't just disappear into the background like many astronauts. Instead, he focused on space research and education, becoming a public advocate for science. He frequently participated in lectures and activities, helping countless young people enter the space field and igniting the spark for others to chase their space dreams. Additionally, Wardens worked on various space exploration technologies, particularly in flight and communication, making lasting contributions to future space missions. Although he didn't physically stand on the moon, his influence on space history and the next generation of explorers is undeniable. Wardens passed away in 2017 at the age of 88, leaving behind a legacy that still motivates people to explore the unknown. His story isn't just a chapter in space history, it's a timeless reminder of the power of curiosity and exploration. On July 26, 1971, Apollo 15 launched from Kennedy Space Center in Florida, starting a historic and highly valuable mission. The goal wasn't just to land on the moon again, it was to conduct more in-depth exploration, particularly in the field of geology. The three astronauts for this mission were, of course, the heroes we've just discussed, David Scott, James Irwin, and Alfred Wardens. Their task was to land on the moon, conduct scientific experiments, collect samples, and return those samples to Earth for further analysis. On that day, Apollo 15, riding atop the mighty Saturn V rocket, blasted off from Kennedy Space Center. The Saturn V was the most powerful rocket ever built, designed to send the three astronauts into space and ultimately to the moon. Its successful launch was a defining moment in American space history and laid the foundation for the continued Apollo missions. After the launch, the crew spent about 3 days in transit, and by July 29, they were in lunar orbit, ready to begin their lunar landing mission and ensure all their scientific tools were in perfect working order. On August 1, the lunar module Falcon separated from the command module and began its descent to the moon's surface. The target was the Hadley-Apollo region, located on the eastern part of the moon, near the Apollo Mountains. This area was known for its rich geological features, making it one of the best spots for scientific exploration. The landing took place on August 1 at 22:16, and the astronauts touched down precisely on the moon's southern side, near the Hadley crater. This region's geological backdrop offered scientists an excellent opportunity to study the moon's history and evolution. The astronauts spent a total of 33 hours on the lunar surface, conducting extensive scientific research and collecting samples. One of their primary objectives was to study the moon's geology, sampling rocks, soil, and impact craters to understand the moon's structure and evolution. At the start of their mission, Scott and Irwin began a preliminary survey of the lunar surface, using various geological tools to collect samples. Each sample had to be handled carefully to ensure that it would provide accurate data for future research. With the moon's harsh environment, the astronauts had to be extra cautious to prevent contamination of their samples. And with that, Apollo 15 wasn't just another moon landing, it was a giant leap forward in our understanding of the moon, paving the way for future missions and the continued exploration of our solar system. Let's talk about the Apollo 15 mission and those incredible lunar samples that David Scott and James Irwin collected. The dynamic duo didn't just wander around picking up rocks casually, oh no, they were on a mission. Armed with tools like pickaxes and sample tubes, they gathered rocks and soil from the Hadley crater region on the moon's surface. And let me tell you, that area wasn't just a random spot, it was ground zero for some of the moon's most intense geological activity. Think of it as the moon's version of a rough neighborhood, where craters and weathering have left their mark on the surface for billions of years. The astronauts weren't just wandering around haphazardly, they had a detailed checklist, with specific regions to target and carefully selected samples to collect. These weren't just dust on the moon type of rocks. No, they were deep, insightful samples, some from deeper layers of the moon's surface. This was NASA's way of trying to get a peek inside the moon's mysterious interior. They took samples of basalt, lava rock, and various types of lunar soil, helping scientists piece together the moon's impact history, weathering process, and mineral composition. The collection process was meticulous. Every rock and piece of soil was tagged with precision, ensuring that the location of each sample was well documented. Because every region of the moon has its own geological features, these samples reflected different geological periods of the moon's history. Scott and Irwin weren't just looking for quantity, they also focused on quality and representativeness. But it wasn't just pickaxes and tubes. No, Scott and Irwin had high-tech gadgets on hand too. They used geological hammers to break rocks and spectrometers to analyze the chemical composition of the rocks and soil. These instruments helped them quickly assess which samples were most valuable for their research. It was like they were using science as their GPS. On August 2, the astronauts embarked on their first moonwalk and began their geological survey of the lunar surface. Their first stop was the area around the Hadley crater, where they studied the moon rocks. This region was packed with information about the moon's weathering and impact history. The more they examined, the better scientists could understand how the moon formed. As the mission progressed, Scott and Irwin hopped into the Lunar Rover. Yes, the moon had its own supercar, expanding their exploration. This wasn't your everyday go-kart. The Lunar Rover could hit speeds of up to 13 kilometers per hour, which might not sound fast, but trust me, on the moon's uneven terrain, that was like an F1 car. The rover wasn't just for fun, though. It enabled the astronauts to cover more ground and bring samples back to the lunar module, making sure everything was preserved for later analysis. They didn't just collect rocks, they collected the history of the moon itself. In fact, thanks to the rover, Scott and Irwin covered a massive 17.5 kilometers on the lunar surface. Now, that's a lot more than the previous Apollo missions managed. They were cruising across the moon like it was their own private racetrack, collecting samples from spots that would have been impossible to reach on foot. But it wasn't just about collecting rocks. Oh no, these two astronauts were also busy performing scientific experiments. They analyzed the lunar surface's weathering layers, studied impact craters, and looked into other geological features. The more they researched, the more we learned about the moon's billions of years of changes. By the end of their mission on August 3, they had collected a whopping 77 kilograms of lunar samples. Talk about taking a piece of history back to Earth. These samples were critical for advancing our understanding of the moon's history and evolution. On August 5, Scott and Irwin completed their work on the lunar surface and made their way back to the lunar module. After reuniting with Alfred Wardenz, the command module pilot, they prepared for their journey back to Earth. By August 7, the Apollo 15 command module splashed down into the Pacific Ocean, about 1,500 kilometers off the coast of Hawaii. The recovery was smooth, and the mission ended successfully. Now, let's get into the real star of the show, the Lunar Rover, the moon supercar that made Apollo 15 such a game-changer. If you've ever watched footage of the Lunar Rover in action, you know it was like watching a sports car tearing across the moon. Picture this, a vehicle that could zoom across the lunar surface, dodge craters, and carry samples. Pretty futuristic, right? The rover didn't just let the astronauts cruise around, it left a lasting mark on the history of human exploration on the moon. Let's take a closer look at the rover's design. The goal was simple: build something that could handle the moon's extreme conditions, low gravity, extreme temperature swings, no atmosphere, and a surface covered in soft dust and jagged rocks. The Lunar Rover was designed with cutting-edge technology to tackle all of these challenges. The rover wasn't massive, but it was perfectly sized for the job. It measured about 3.1 meters long, 1.8 meters wide, and 1.1 meters high. Compact enough for good maneuverability, yet large enough to carry equipment and astronauts comfortably. And the weight? Just 210 kilograms. A feather-light ride on the moon, where gravity is only 1/6 that of Earth. The rover's tires were designed with moon rocks in mind. They were made of aluminum alloy and wrapped in titanium mesh. These babies were tough, able to handle the rough lunar terrain. Each tire was about 0.8 meters in diameter, providing stability and grip on the moon's uneven surface. The rover used a four-wheel drive system, with each wheel powered by an electric motor. This setup gave it the flexibility it needed to navigate the low-gravity environment, especially in the soft lunar dust. The rover didn't just roll, it powered through, keeping the astronauts steady as they explored. And let's talk power. This vehicle didn't run on gas. Nope, it was powered entirely by batteries, nickel-hydrogen batteries, to be precise. These batteries worked well in the extreme temperature shifts on the moon. On a full charge, the rover could keep moving for up to 8 hours, plenty of time to get a lot done on the lunar surface. But wait, there's more. The rover also had solar panels to recharge its batteries. Since the moon has no atmosphere, the sun's rays hit the surface much more directly, making it perfect for solar energy. The rover made good use of that, ensuring the astronauts had enough power to keep exploring. And there you have it, the Lunar Rover, a lightweight, high-tech vehicle that enabled Apollo 15 to cover more ground, collect more samples, and make history. Let's talk about the Apollo 15 mission's moon supercar, the Lunar Rover. Now, if you've ever seen footage of the Lunar Rover in action, you know it's like a space-age version of a race car. Picture this, a vehicle that zips across the moon, dodging craters and rocks while collecting samples. It sounds like something out of a sci-fi movie, right? Well, Apollo 15 brought this supercar to life, and it wasn't just a flashy ride, it revolutionized how we explore the moon. First, let's dive into the design. The Lunar Rover was no ordinary vehicle, it had to handle the extreme conditions of the moon. Low gravity, uneven terrain, and temperature swings that could make your head spin literally. So, it was designed with cutting-edge technology to handle all of these challenges. The rover's compact size made it ideal for navigating the lunar surface. It was 3.1 meters long, 1.8 meters wide, and about 1.1 meters tall, big enough to carry astronauts and gear, but small enough to handle tight turns in rocky areas. But here's the kicker, it only weighed 210 kilograms. That's ridiculously light, considering the moon's low gravity. With this design, the rover could glide over the moon's surface like a dream, without sinking into the dust or getting stuck in a crater. The wheels, oh, they were something else. Made from aluminum alloy and wrapped in titanium mesh, these tires were built to withstand the harsh lunar surface, full of jagged rocks and soft dust. The wheels were about 0.8 meters in diameter, and with their unique design, they provided a ton of traction, helping the rover grip the moon like a mountain climber. Now, let's talk about the driving experience, because this is where it gets fun. The Lunar Rover had a four-wheel drive system, powered by electric motors. Each wheel had its own motor, so the rover could cruise through the moon's low gravity with ease. And guess what? It wasn't just a simple push of a pedal. The rover had a sophisticated electric control system that allowed it to zip around, even in the soft lunar dust, with incredible agility. And what about the power? The Lunar Rover was powered by nickel-hydrogen batteries that could last up to 8 hours on a full charge, enough time for the astronauts to explore and collect samples to their heart's content. And the best part? The rover had solar panels that could recharge its batteries using the sun's rays. The moon's lack of atmosphere made the sun's energy stronger, so the solar panels worked overtime to keep the rover running smoothly. But the rover wasn't just about looking cool, it was a game changer for the mission. For the first time, astronauts could travel long distances on the moon's surface. Instead of walking a few hundred meters, they could now zoom across the landscape, covering up to 17.5 kilometers. That's a huge leap compared to previous missions, where astronauts could barely walk a few hundred meters before heading back to their lander. Scott and Irwin used the rover to explore the area around the Hadley crater, an iconic lunar feature. Thanks to the rover, they could easily cross the rugged terrain and reach geologically rich areas that would have been impossible to explore on foot. With it, they collected samples, ran experiments, and explored different lunar regions, getting a much clearer picture of the moon's geological history. Now, let's be honest. Apollo 15 wasn't just about driving a cool moon car. This mission was about science, and lots of it. With the rover, the astronauts didn't just gather rocks, they conducted real geological research. They studied the moon's surface layers, impact history, and mineral composition. The samples they collected, 77 kilograms of moon material, are still being studied today, providing valuable insights into the moon's evolution. But the rover wasn't just useful for science, it also made life a lot easier for the astronauts. The rover's design allowed Scott and Irwin to conserve their energy, moving around the moon with ease, covering greater distances, and completing their tasks in less time. The rover gave them a sense of freedom on the moon that wasn't available in earlier missions. And speaking of freedom, the Lunar Rover didn't just change how astronauts explored, it laid the groundwork for future innovations. The rover's four-wheel drive, autonomous systems, and precision controls directly influenced the development of modern self-driving cars. It was a real-life prototype for the autonomous vehicles we see today. The rover's electric motors, sensors, and control systems? All of these features are now key components of the tech in autonomous cars and electric vehicles. But wait, there's more. The Lunar Rover also had a significant impact on wireless communication. Apollo 15's astronauts relied on radio frequencies and low-frequency signals to stay in contact with Earth. That might not sound like much, but the communication tech used on the moon helped pave the way for modern satellite communication and mobile networks. Yes, you can thank Apollo 15 for playing a part in making your cell phone work. So, when you think of Apollo 15, don't just picture astronauts in spacesuits collecting rocks. Think of the technological leaps it sparked, from autonomous vehicles to satellite communication. It wasn't just a trip to the moon, it was the launchpad for many of the tech innovations we take for granted today. In the end, the Lunar Rover didn't just make the mission more efficient, it expanded humanity's reach on the moon and helped us take steps toward exploring not just the moon, but other planets as well. Let's talk about the Apollo 15 mission, and no, it wasn't just about driving a cool moon rover and snapping a few pictures of the lunar surface. It was way more important than that. The astronauts on Apollo 15 had a critical job, collecting lunar rocks and soil samples. Those seemingly ordinary rocks weren't just souvenirs from the moon, they were treasure troves of scientific information. These samples didn't just help scientists understand the moon's history, but they also uncovered potential resources that could have huge applications for Earth's future. The samples from Apollo 15, especially the basalt, lava rocks, and lunar dust, were a gold mine for researchers. These rocks told a story of intense impacts and volcanic activity on the moon's surface. This wasn't just academic stuff, these findings were game changers for planetary science and even mineral research. Some scientists even discovered that the moon's rocks share similarities with rare metals on Earth, giving new hope for future mining ventures in space. But the influence didn't stop there. The research into these lunar samples has a direct connection to future planetary resource mining and moon base construction. As the technology for studying lunar samples has advanced, scientists have started applying similar techniques for resource extraction on other planets. For example, today's Mars missions are already planning to use similar mining technologies to extract resources from Mars. And it all started with Apollo 15's rock samples. Now, let's talk about the real star of the show, the Lunar Rover. The rover wasn't just a fancy moon buggy. It was a breakthrough in technology that had huge implications, not just for space exploration, but for everyday life and even the military. The rover's remote control system and high-precision navigation laid the groundwork for military tech, including reconnaissance drones, laser-guided missiles, and surveillance satellites. The rover was, in a sense, a tech pioneer, helping to shape the military technologies of tomorrow. Who would have thought a little moon car could leave such a big footprint? But here's the kicker, the rover's influence wasn't just military. Apollo 15's mission helped lay the groundwork for satellite defense systems, laser guidance technology, and even GPS systems. The rover's design and tech innovations had a long-lasting impact on how we create precision-guided missiles and even today's military satellites. So next time you see a military drone soaring across the sky, think back to Apollo 15 and its moon car. Now, moving beyond the moon, Apollo 15 also provided valuable lessons for deep space exploration. The rover's design and the mission's technologies didn't just stop at the moon. They were stepping stones to future missions like those to Mars. The lessons learned from the rover, especially the electric drive system and scientific tools, were directly used in designing future Mars rovers like Curiosity and Perseverance. In fact, many of the systems in today's Mars rovers, like electric motors and precision scientific instruments, trace their roots directly back to the Apollo 15 mission. So when NASA sends its next rover to Mars, it's standing on the shoulders of the Apollo 15 team. And let's not forget about the computing technology that powered Apollo 15. While the computers used during the mission may seem ancient by today's standards, clunky and slow, they actually pioneered the way for the real-time operating systems and embedded computers we rely on today. The computers on Apollo 15 helped astronauts navigate their spacecraft, control flight paths, and collect data. These early computers laid the foundation for the real-time data processing we use today, whether it's in flying drones or self-driving cars. The advancements from Apollo 15 didn't just revolutionize space exploration, they helped to kickstart the computer revolution we're living through today. From military command systems to medical devices, from weather forecasting to big data analysis, the Apollo 15's computing technology made it all possible. We may not be thinking about it when we check our phones or analyze the weather, but the Apollo missions helped build the foundation for the digital age we now take for granted. In summary, Apollo 15 wasn't just a giant leap for mankind's space exploration, it was a springboard for countless technological advancements. The lunar rover's design directly influenced the development of self-driving cars, and the lunar samples opened the door to planetary resource mining. The communication tech and satellite navigation systems we use today? Yep, Apollo 15 helped lay the groundwork for all that. So, next time you pull out your phone, hop into an autonomous car, or watch a new Mars rover land on the red planet, remember this: it all started with Apollo 15. Those astronauts didn't just leave footprints on the moon, they left a legacy of innovation that shaped our present and continues to drive us into the future. And as for us Earthlings, well, maybe we'll have to wait until the next Moon rover gets its self-driving upgrade before we get a chance to test it out. But don't worry, there's no traffic on the moon, although parking might be a bit tricky. At least the view of space? Top-notch. The people who change the world. Usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.